Welcome to Let Us Start Educational Channel. This channel is for teaching IIT Physics. So, in our last sessions, we discussed about the physical properties, fundamental quantities, and fundamental units. So, 7 fundamental quantities are there. Why we call these 7 as fundamental quantities? These 7 quantities are internationally standard. These 7 quantities are internationally standard and their units are fixed. We call their physical quantities, unit of their physical quantities with this name and used to write this notation. So, totally 7 fundamental physical quantities are there and their units are given here, and the notation for this unit is given here. Mass is kg, for length is for length, unit is meter, for time unit is second, for temperature is Kelvin, for luminous intensity is CD, for electric current we express the unit A, for amount of substance express the unit mole. So, many physical quantities are there in physics. Physical quantities are physical properties. These physical quantities are physical properties describe the object. Suppose that every object in the universe has mass and it has length and it has volume. When you apply some force, we describe the object, motion of the object. So when it is going, how much is the velocity of that object? These are all the physical properties of that object. So in our last session, we discussed about the physical properties of fundamental quantities. What do you mean by fundamental quantities? Fundamental quantities units not depend on any other physical quantities. Why? Their units are internationally standard and they represent with the symbols meter, length, time and temperature as K and current as A. So, they provided this internationally different units for fundamental units. Next, what are derived units and derived quantities? Fundamental units or fundamental units of fundamental physical quantities are fixed internationally. They can't depend on any other units. So we call them as fundamental units. Other than these 7 fundamental units, so many physical properties are there. So many physical quantities are there. Units of these physical quantities are derived from the combination of these 7 physical quantities. If we can take any physical quantity other than these 7, we calculate them these as the combination of 7 physical quantities. So suppose that area is there. What is the formula for area? Is length into breadth. What is the unit for length? How can you express the length of that object in meters? Breadth in meters. So what is the unit of area? Meter square. Here meter is the standard unit or fundamental unit. Here length depends on this fundamental unit length. Here area depends on the fundamental unit length. So this area is derived unit and it is derived quantity, like this. Volume is there. What is the formula for volume? Length, breadth and height. So length is expressed in meters, breadth is expressed in meters and height is expressed in meters. So unit of volume is meter cube. Here volume depends on the fundamental unit length or fundamental unit meter. So volume is also a derived unit. Next, let us calculate the unit for velocity. Velocity is nothing but distance by time. Distance means length by time. What is the unit for length? Meter. What is the unit for time? Second. So what is the unit of velocity? Meter per second. Velocity is the combination of fundamental unit meter and time second. So velocity is also a derived unit. It is the combination of meter and second. Next one is acceleration. Acceleration means velocity by time. What is the unit of velocity? Meter per second. What is the unit of time? Second. So meter per second square is the unit of acceleration. Next one is force. Force is equal to ma. M for mass, kg. A for just now we calculate the unit of acceleration is meter per second square. So unit of force is kg meter per second square. Like this we can calculate the work. Work is force into distance, that is kg meter per second square into distance. So kg meter square by second square. Like this we can calculate the units of the different physical quantities. So main derived quantities are area, volume, velocity, acceleration, force, work, energy and charge. When these are the very fundamental derived quantities. When we know these derived physical quantities units, it is easy for you to write the units of any other derived quantities. So now our aim is how can we write the dimensional formula. Suppose that area is there. Just now we discussed that area is expressed in meter square. In dimensional formula we can write length as like this. mass as like this, time as like this, so current as like this. So their unit is expressed like this in dimensional formula. So what is the dimensional formula of area? How can you write the dimensional formula of area? Dimensional formula of area is, this formula is length into length. So L square. Here 2 means area is 2 units in length. That is no mass. 0 units in mass. 0 units in time. Like this we can express it. So like this we can calculate the dimensional formula of velocity, acceleration and different units. Next one is velocity. Just now we calculated this. Velocity is distance by time. That means length by time. Length is expressed in meters, so meter per second. So length is expressed in L. Time is expressed in T. So here T inverse. Next one is acceleration. A is equal to V by T. What is the dimensional formula of velocity? L. L T inverse by what is time T? L T power minus 2. Like this we can calculate dimensional formula of different units. So list of dimensional formulas are given here. Let us discuss. Area. What is the formula for area? Length into length. So dimensionally it is expressed as L square. That means area are 2 in length, 2 units in length and 0 units in mass and time. Next one is volume. What is the formula for volume? Length, breadth, height, or length, length, length. Length is expressed in L. So its dimensional formula is L cube. Next one is velocity. Velocity means distance by time. Distance is expressed in L and time is expressed in T. So its dimensional formula is LT inverse. Next one is acceleration. Acceleration means velocity by time. So dimension formula of velocity is LT inverse. So dimension formula of acceleration is LT power minus 2. Next one is momentum. Formula for momentum is mass into velocity. Dimension formula of mass is capital M. Velocity is LT inverse. So dimension formula of momentum is MLT inverse. Next one is force. Force means mass into acceleration. Mass is expressed in capital M, and acceleration is L T power minus 2. So dimension formula of force is ml T power minus 2. Next one is work. Formula for work is force L square T power minus 2. Whenever we know the formula, it is easy for you to write the dimension formula of any physical quantity. Just we know the formula of physical quantity. Next, couple or torque. Formula for this is force into perpendicular distance or length of arm. Its dimension formula is ml square T power minus 2. Next one is kinetic energy. Whatever it may be the energy, kinetic energy, potential energy, heat energy, whatever it may be the energy, whatever it may be the formula of energy, dimension formula is ml square T power minus 2. Formula for kinetic energy is half m v square. Dimension formula is ml square T power minus 2. So like that, dimension formula of potential energy is also ml square T power minus 2. Formula is different, that is mgh. Next one is power. Power is nothing but work by time. So dimension formula of it is ml square T power minus 3. And next one is density. Formula for density is mass by volume, and its dimension formula is ml power minus 3. Next one is specific gravity. Specific gravity is the ratio. So a ratio has no dimensions. Pressure is nothing but force by area. So its dimension formula is ml inverse T power minus 2. Stress. Stress is nothing but force by area. So its dimension formula is ml inverse T power minus 2. Next one is strain. Strain is the ratio of lengths. So it is dimensionless quantity. It doesn't have any units, that means it doesn't have any dimensions. Next one is elasticity. Elasticity is stress by strain. Elasticity has the dimension formula of stress. ml inverse T power minus 2, ml inverse T power minus 2. Next one is surface tension. Formula for surface tension is force by length. So dimension formula of force is ml T power minus 2. So surface tension is m T power minus 2. Next one is surface energy. Formula for surface energy is work by area. Dimension formula of work is ml square T power minus 2 and area is L square. So dimension formula of surface energy is ml T power minus 2. Next one is angle. Angle is arc by radius. So it is the dimension formula of same function. So it is the ratio. A ratio has dimensionless quantity. Angular velocity, angle by time. So angle doesn't have any units, so time is expressed in T inverse here. Next one is angular acceleration. Angular acceleration has the dimension formula T power minus 2. Moment of inertia. Moment of inertia means mass into radius of gyration. Radius of gyration is nothing but length. So its dimension formula is ml square. Frequency is number of vibrations per time. So its dimension formula is T inverse. Next one is coefficient of viscosity. Formula for coefficient of viscosity is force by area by velocity by distance. Till now we discussed about dimension formulas of force, area, velocity and distance. Substitute all these values in this. Get the result. Coefficient of viscosity dimension formula is ml inverse t power minus 1. Gravitational constant, we call this capital G as a universal gravitational constant. So it is a very important one. One problem is given in JEE Mains in this units and dimensions chapter. So to learn dimension formulas of different physical quantities is very important. First of all, we have to know the formulas of that physical quantities. First we have to learn the formula of that physical quantities and we must practice to write the dimension formulas of that physical quantities. So dimension formula of gravitational constant is m inverse L cube t power minus 2. Just now I tell that heat energy, whatever it may be, the energy, heat energy, kinetic energy, potential energy, whatever it may be, the energy dimension formula is ml square t power minus 2. And temperature is expressed in K means Kelvin. Next one is specific heat. Specific heat is nothing but heat energy by mass temperature difference. Just now we discuss dimension formula of heat energy, mass and temperature. So specific heat dimension formula is L square t power minus 2 K inverse. Next one is angular momentum. Formula for angular momentum is moment of inertia and angular velocity. So its dimension formula is ml square t inverse. Thermal conductivity formula is heat into distance by area, temperature difference into time. Substitute the dimension formulas of all these. We get the thermal conductivity dimension formula mlt power minus 3 K inverse. Next one is latent heat. The formula for latent heat is heat by mass. So its dimension formula is L square t power minus 2. And how many units of mass is in latent heat? 0 units of mass is in latent heat. Next one is force constant. Force constant dimension formula is mlt power minus 2. Planck's constant, this is also important one. Formula for this is E is equal to h nu. Nu we can write as 1 by t. So we get h is energy into time. Dimension formula of it is L square t inverse. Next one is Boltzmann constant. Formula is energy by temperature. So its dimensional formula is ml square t power minus 2 K inverse. Radius of gyration. Dimension formula is L. Electric current A. Luminous intensity C. The amount of substance mole. And the formula for electric resistance is work by coulomb by current. So we convert these coulomb into currents. U is equal to IT. So dimension formula of this electrical resistance is ml square t power minus 3 A power minus 2. Next one is entropy. Is nothing but heat by temperature, and its dimension formula is ml square t power minus 2 K inverse. Next one is magnetic flux, means field strength into area. So formula for this magnetic flux is expressed in pi, the symbol 5. So its formula is FA by QB. B means F by Q. F means force, A for area. Q for charge. Q means current into time. And V means velocity. And substitute the dimension formulas. We can get the dimensional formula of magnetic flux is ml square T power minus 2 A inverse. Next one is permittivity. Formula for this permittivity is Q1 Q2 by 4 pi pi r square. Q means charge. Charge is current into time. So we convert this as A square T square. And dimension formula of it is m inverse L power minus 3 T power 4 A square. The dimension formula of permittivity. First of all, its formula is 4 pi F R by 2 I1 I2. Just remember one thing, we don't have any units for these numbers 2, 4, pi. It's just values, they have fixed value, so they don't have any units. Dimensional formula of this permeability is mLT power minus 2 A power minus 2. Last one is energy density. Energy density is energy by volume. So its dimensional formula is mL inverse T power minus 2. Till now we discussed about so many important physical quantities and their dimensional formulas. One question is given on these dimensional formulas in JEE Mains. So it is important to learn formulas of all physical quantities. We must practice to write the dimension formulas of physical quantities. So dimension formulas is expressed in M, mass is in M, length is in L, time is in T, current is in A, temperature is in K. Like this we can write the dimension formula of physical quantities. So I feel this class is helpful for you in learning dimension formulas of physical quantities. They are very important one, and one question is given in JEE examination. So first of all you must learn the formulas, and it is easy for you to write the physical dimension formula of any physical quantities. This video is useful to you. Like it, comment it and share it, and subscribe this channel for getting more comfortable and better videos. To encourage me, subscribe my channel.